Today is 29th January 2026, and today we are starting the topic sound. Sir, what is sound? So, before starting sound, you should know there are two types of waves. Number one, transverse wave. Number two, longitudinal waves. So, sound is a longitudinal wave. And जी बेटा कोर्स तो हम आपके साथ पूरा खत्म कर चुके हैं। एक टॉपिक भी आपके साथ बाकी नहीं बचा हुआ है। तो साउंड कंप्लीट करने के बाद नेक्स्ट वीक से क्या पढ़ाना है हम आपसे पूछ के फिर पढ़ाएंगे जैसा आप बोलेंगे। वैसे इंशाल्लाह कोई नया टॉपिक शुरू कर लेंगे। ठीक है। लेकिन अभी हम लोग बेटा हाँ नहीं आप अगर ले लें तो अच्छी बात है। ले लेंगे तो आपका ये टॉपिक जाहिर सी बात है और अच्छा हो जाएगा बेटा। ठीक है। अच्छा जनाब, the topic is longitudinal wave today. Sir, what is longitudinal wave? I am explaining. Longitudinal wave is explained as consider these are air particles. These are air particles. And consider here is the loudspeaker. Consider here is a loudspeaker. And you know loudspeaker produces sound wave. And when sound is produced by loudspeaker, then sound is traveling in this direction. And when sound passes through air, then these air particles vibrate parallel to the sound wave. The sound wave traveling horizontally, but you can see the particles are vibrating left right. The particles are vibrating left right. So the keyword is, sir, when particles of medium vibrate parallel to the wave. I am not writing proper definition because I will send you my notes in which all definitions are properly written. So I am explaining only the keyword. Sir, when particles vibrate parallel, then it is called longitudinal wave. And when particle vibrate perpendicular, then it is called transverse wave. As well as when these particles vibrate parallel. And I should show you an animation in which particles are vibrating parallel. You can see, but this is a loudspeaker. This speaker is producing sound wave traveling towards right hand side, and these particles are moving parallel with the sound wave. And in this static diagram, you can see these particles are very close to each other. Where particles are very close to each other, then this point is called compression. Where the particles are compressed, then it is called compression. And the region where particles are far apart, then this region is called rarefaction. And in this diagram, you can see compression to compression. This distance is called wavelength. And you know, wavelength can be measured by a ruler. Wavelength can be measured by a ruler. But in your IGCSE, I have seen the diagram which are given in exam. They draw like this. If the lines are drawn very close to each other, the lines are drawn very close to each other. It means it is the region where particles of the medium are very close to each other. And this region is called compression. And between compression, I am drawing lines at a large distance. And it shows, sir, it is rarefaction. So when longitudinal wave passes through a medium, when longitudinal wave passes through a medium, consider on the left hand side we have a speaker. Consider sound wave is traveling in this direction. Then particles of the medium will be vibrating parallel. When particles vibrating parallel, then this is called longitudinal wave. Longitudinal waves are composed of compressions. Sir, compression is the region where particles are very close to each other, as well as compression is a high pressure region. Compression is a high pressure region. And this region where particles are far apart, then obviously the pressure will be low. So low pressure region is rarefaction, and high pressure region is called compression, and compression to compression, the distance is called one wavelength. So in real, particles are moving like this, but in your exam, usually longitudinal waves are expressed like this. Sir, what is the difference between longitudinal wave and sound wave? So the answer is sound wave is an example of longitudinal wave. Sound is an example of longitudinal wave. Okay. Sir, usually sound is considered, sir, which is detected by our ear. Sound is the energy which is detected by our ear, and we are human, and there is a limitation of our detection. Sir, what does it mean? The meaning is if the frequency of longitudinal wave is at least 20 hertz, and if it is maximum 20,000 hertz, if the frequency of longitudinal wave, if the frequency of longitudinal wave is between 20 hertz and 20,000 hertz, then such longitudinal wave is called audible sound. We human can detect sound between 20 hertz and 20,000 hertz. And the sound having frequency less than 20 hertz, then it is called infrasonic. Then it is called infrasonic. And if the frequency is greater than 20,000, it is called ultrasonic or ultrasound. And remember, neither ultrasound nor infrasound we cannot detect. Our human hearing range lie between 20 hertz and maximum 20,000 hertz. It is the range of longitudinal wave which we can detect. Further, you know the speed of sound is constant and you have to memorize these numbers. Speed of sound in air is usually used 340 meter per second. But if you write 300 or 400, all are acceptable. But its value at 0 degrees Celsius, actually speed of sound depends upon temperature. So its value is 340 meter per second. And if you are dealing speed of sound in a liquid like water, then we use this number 1500 meter per second. And if we go in a solid or in a metal, then the speed of sound is considered 5,000 or 6,000 meter per second. So you can see the speed of sound in solid liquid gas. So it is slowest in air and fastest in metals. And if there is no medium, if there is no medium, you know, in vacuum, in space, no medium available, so the speed of sound is zero because sound cannot travel through vacuum. So you should note down and you should memorize these numbers. Okay. And now we are moving forward about sound. Sir, sound, when we listen sound, There are two characteristics in sound. Number one, pitch of sound. Number two, loudness of sound. There are two characteristics of sound. Number one, pitch of the sound. Number two, loudness of the sound. Sir, what is the meaning of pitch? But a pitch means if you listening a sound of a child, or if you are listening a sound of a girl, then their sound is usually shrill sound. And shrill sound is produced by high frequency. In our vocal cord, in our throat, there is a vocal cord, and this cord vibrates and it produces sound. If the frequency of vocal cord is high, then it produces shrill sound. And you know, shrill sound is a child sound or a girl sound. But if the frequency of vocal cord is low frequency, then remember low frequency, low pitch sound is a grave sound. And usually male singer sound is a grave sound. And I will share you a video in which a teacher is producing different pitch sound by different musical instruments. And when you watch that video, then the pitch of sound topic will be cleared. Otherwise, for your examination point of view, you should know, sir, pitch of sound means if the sound is shrill, then it is a high pitch or a high frequency sound. If the pitch of sound is grave, male singer sound, then it is a low pitch and low frequency sound. And sir, what is the meaning of loudness? Sir, loudness means when we talk someone. So sometimes some people talk at a very loud sound, and are some students speak in a very faint sound, very quiet sound, very low loudness sound. And sometimes it is very difficult for a teacher to detect what a student is saying. So loudness of sound means the sound of the student is loud or a faint, a quiet sound. It is called loudness. And sometime in exam, you are given a trace. Consider I am showing you a trace, or what is trace? You know, in oscilloscope. Sir, what is the oscilloscope? Oscilloscope is a device which can display sound on screen. If you connect a microphone with oscilloscope, consider this is a microphone, and this microphone is connected with the oscilloscope, and consider this microphone is detecting sound, and now the sound wave is displayed on the screen. Consider the screen showing like this. This is the trace of sound. This is the trace of sound. In this trace, along x-axis, sir, there is time. There is time. And along y-axis, you know the height of the wave, it is called amplitude. Height of the wave, it is called amplitude. So if I ask you to draw a sound of loud sound, I am asking you to draw a loud sound. Sir, loud sound always displayed by large amplitude. If the amplitude of the wave is large, if the amplitude of the wave is large, then it is trace of loud sound. And amplitude of this black wave is small amplitude. If the amplitude is small, then it means it is a trace of faint sound. Yeah. Sir, when sound wave is displayed on oscilloscope, then if the sound is loud, if the sound is loud, then its amplitude will be large. You can see the height of the wave is large. If amplitude of the wave is large, then such a sound is called loud sound. Okay? And if someone is speaking at very low loudness, if a student is speaking at a very faint sound, then this is the image of faint sound. So I can say loudness of sound is expressed by amplitude of the wave. If the amplitude is large, then it is a loud sound. And if the amplitude is small, then it is a faint sound. So it is the difference of loud and faint sound. Number one. Number two, if I ask you, consider I am giving you a sound, consider this is a sound wave, and consider this sound wave completing one cycle, consider in 10 milliseconds. In 10 milliseconds. This is 0, this is 5, this is 10, this is 15. As I said, along x-axis, there is a time. There is a time. Okay. And you know, frequency is inversely proportional with time. So if I ask you to draw the sound of high frequency, so if the frequency is high, if the frequency is high, then time will be small. And if time will be small, then the wave must be completed within 5 milliseconds. So I can say, so the black wave having long time and low frequency sound. Low frequency sound is black wave, and the blue wave, so the blue wave is high frequency sound. When the frequency is high, when the frequency is high, it will take short time. If the frequency is high, it will take short time. So short time sound I have displayed on the screen. So I am summarizing the topic. The topic is, so there are two characteristics of sound. Characteristic number one, pitch. Sir, what is the meaning of pitch? Pitch means shrill sound or a grave sound. Girl sound or child sound is a shrill sound, and grave sound is a male sound. Grave sound having low frequency, shrill sound having high frequency. Loudness means the sound is loud or a faint. Okay, and we will solve the question, then I will explain you further. And now I think we can start questions from past paper sheet. This is our past paper sheet, and in this past paper sheet, now we are solving questions on sound. The topic is sound, and this is sound wave which is expressed in front of you. And in this question, the question is, what is compression in this diagram? And label with C. Sir, I have explained this is compression. So this is compression, and sir, this is compression. These three C's representing compression. And now, what is rarefaction? Rarefaction. And label it as R. Rarefaction. So rarefaction is here. So rarefaction is here. Rarefaction means where particles are far apart from each other. So these are three rarefaction and these are three compressions. And now you are given, so the wavelength is 0.45 meter. Wavelength is 0.45 meter. So rarefaction to rarefaction, it is 0.45 meter. But the question is, Draw 0.90 meter. This is a question. Read the question. The question is draw an arrow to represent 90 meter. Sir, wavelength is 45 meter and we have to draw an arrow of length 90 meter. So this arrow which I have drawn and now I am converting into green color. Actually, this is not one wavelength. Actually, it is equal to two wavelengths because one wavelength is 0.45 meter and two wavelength is 0.90 meter. In this question, they are asking to draw 90 meter. So I have drawn not 0.45 meter, but I have drawn 0.90 meter. And now the next part of the question, sir, you are given frequency and you have to calculate speed of sound. Everyone knows speed is the product of frequency and wavelength. Sir, frequency is 750. Frequency is 750 and wavelength, sir, wavelength is 0.45. But Amna, can you multiply these number? 750 by 0.45, Amna? It will give you the speed of the wave. 337, we can round off to 340 because in the next part, they are asking. But Amna, they are asking this is speed of sound 340 meter per second. Amna, can you tell me in which medium the speed of sound is 340? Is it what? Yes, it is air. You should memorize this number. In air, the speed of sound is 340 meter per second. And the next part is give the reason. So the reason is it is a fixed value. It is constant speed of sound in air. So sir, it is a constant value, not a reason. Acha ji. Now the next part. The next part. The next part is consider we have two uh, longitudinal waves. One of them is ultrasound. One of them is ultrasound, and ultrasound. This is ultrasound, and another sound of frequency 750. Sir, you are given two options. Option number one, sir, you are given sound of frequency 750 hertz, and you are given ultrasound. The question is, what is similarity between them? What is one similarity between them? Sir, ultrasound is a longitudinal wave and sound is longitudinal wave. So the similarity is, sir, both are longitudinal wave. Both are longitudinal waves. Okay, beta. Both are longitudinal waves. And now the next part state one way these this sound wave is different from ultrasound. The sound wave is different from ultrasound. What is the difference between them? So the answer is, sir, sound of frequency 750 hertz is audible. This is audible. If the frequency of sound is 750 hertz, then it is audible. But ultrasound is not audible. So the difference between them, sound 750 is audible and ultrasound is not audible. So this question, more than 20,000 hertz. If the frequency is more than 20,000 hertz, then it is ultrasound. And now the question is, what is meant by longitudinal wave. What is meant by longitudinal wave? So the answer is, sir, when particles of medium vibrate parallel to the wave, parallel to the wave is called longitudinal wave, is called longitudinal wave, and composed of longitudinal wave composed of compressions and rarefactions. Longitudinal wave composed of compression and rarefaction. So we have already discussed the definition of longitudinal wave, and now we have a mathematical question. The question is, what is the speed of sound in water? Beta, here can you answer me? What is the speed of sound in liquid? Perfect. So the speed of sound in water or in a liquid, it is 1500 meter per second. And now use this number to calculate wavelength of sound in the ocean, and frequency is given. So V equal to F lambda. Sir, velocity is 1500, frequency is 800, and wavelength I have to calculate. So wavelength is equal to 1500 divided by 800. So you can calculate wavelength in meters. 1.9. 1.9. Okay. So this question is completed, and now we are starting question number 3. The question number 3 is ultrasound wave. Draw two circles on ultrasound waves. Sir, ultrasound wave is longitudinal? Yes. Ultrasound wave is longitudinal? Yes. Ultrasound frequency is more than 20,000. If the frequency is 35,000, it means it is greater than 20,000. So we have only two circles here. Number one, the frequency of ultrasound is 35,000 and it is a longitudinal wave. The next question is about X-ray, which we cannot solve right now because this is not sound wave question. This is not sound wave question. And now question number 4. In question number 4, you are given sound wave is longitudinal wave. You are given sound wave is longitudinal wave, and you have to draw, sketch longitudinal wave in which you have to show compression, you have to show rarefaction, and we have a very limited time for this class. So I am not interested to redraw this diagram. Actually, this is the diagram of sound wave in which you will draw parallel lines very close to each other and you will call it compression. And the lines you will draw at a large distance, you will call it a rarefaction. So you have to draw this diagram for that question. So I am not drawing. So I am not drawing. I am writing question number 1, same question. But you have to draw. And now question number B part. Question number B part. A longitudinal wave passes from one medium into other medium. Okay. The speed of sound is slower in the second medium. So what does it mean? I'm giving you example. For example, this is a swimming pool. In this swimming pool, consider here is a loudspeaker, and when this loudspeaker produces sound, then this sound passes through first water, and you know in water the speed of sound is 1500. And when this sound enter into air, then it slows down. It means there is a difference of speed of sound. Okay. So the question is, sir, what will happen to the frequency of wave? You know, when medium changes, sir, there will be refraction. When medium change, when speed changes, there is refraction. The speed of sound changing, it means there is refraction. And for refraction, you know, sir, frequency not change. In refraction of sound, in refraction of water wave, in refraction of sound wave, sir, frequency not change. Sir, frequency remains constant. Wavelength? Yes, wavelength will be affected. Sir, how it is affected? Sir, V equal to F lambda. As I said, frequency not change. Sir, frequency is constant. So if speed is slowing down, if speed is slowing down, then wavelength will be decreasing. If speed is slowing down, then wavelength will be decreasing. So the answer is the wavelength of the wave will decrease. The wavelength of the wave will decrease. Okay. So sound wave traveling from water into air, all the media are not given. I'm giving you example. In water, you know the speed is fast. In air, it becomes slow. So when speed slower, then wavelength will decrease, but frequency remains same. And now the next part is state a typical value of speed of sound in air. So you will write 340 meter per second. 340 meter per second is the speed of sound in air. And now the next part is very simple. You are given a speed of sound and you have to write their medium. 1500 meter per second in liquid or in water. 5000 meter per second in solid. Okay, you have to write solid liquid gas. Okay. So I'm not writing water. I should write 1500 in liquid. 5000 is the fastest. So the medium will be solid. And 300 is the slowest and it is in air or it is in gas. So we are given these three options. You have to write solid, liquid, gas. So I used solid, liquid, and gas. And now the question is, again, sir, we are given sound wave pattern. We are given. Okay. And this sound wave composed of compressions and rarefactions. Yes. The question is, sir, mark X and Y at the midpoint of rarefaction. In the rarefaction, okay. So I am marking this is rarefaction X, this is rarefaction Y. So these are two rare factions. And now they are asking, what is meant by rarefaction? जी बता रहा पे अब जो आएगा बेटा वो करेंगे ना इन दिस क्वेश्चन दे आर आस्किंग रेयर फैक्शन तो हमने रेयर फैक्शन मार्क कर दिया बिल्कुल कंप्रेशन टू कंप्रेशन इट इज अ वन वेवलेंथ रेयर फैक्शन टू रेयर फैक्शन इट इज वन वेवलेंथ ठीक है बेटा and now the question is what is meant by rarefaction and you have to explain in terms of pressure in terms of pressure so remember in compression particles are very close to each other but in rarefaction sir particles are at a large distance and when particles at a large distance then obviously there will be low pressure there will be low pressure so I am writing the region sorry the low pressure region the low pressure region in which there are few particles and are at large distance is called rarefaction. Rarefaction is a low pressure region, and in this low pressure region, number of particles are fewer, as well as they are at they are at large distance. Then it is rarefaction. In compression, it is a high pressure region in which particles are very close to each other. So this topic is completed. And now the next question is not about sound, but it is a very simple question. But it is not about sound, but I think we can solve it. The question is, sir, consider this is our Earth, this is Moon, and the question is, sir, there is a mirror on the surface of Moon. Consider this is a question. Consider this is a mirror, and this mirror is on the surface of Moon, and we are sending a laser light from Earth to the mirror, and then this light reflected back to the Earth. So we are sending light and then we are receiving light. And the time to send and receiving, the time is 2.56. This is the time. In this time, the light is sent out and received. The speed of sound is given 3 exponent 8. The question is, what is the distance between Earth and sound? We have to calculate distance between Earth and Moon. What is the distance between Earth and Moon? You know, distance is equal to speed into time. Distance is equal to speed into time. Sir, speed is 3 exponent 8. Time, sir, time is 2.56. But the time is 2.56, speed is 3 exponent 8. Sir, what about distance? Sir, we will use 2D. Sir, why? Because D in outgoing, and D for return. The light sent, distance D covered, and light returned, distance D covered. So the total distance become 2D. D outgoing, D incoming. So the total distance is 2D. And if we have to calculate only D, then this 2 should be shifted on the other side. And then you can solve this number, and it will be the distance between Earth and Moon. It will be distance between Earth and Moon. And the same mechanism we will use in echo question. We will solve echo question within 10 minutes. And the same mechanism we will use in that question. Now the next part, though, also next question is a loudspeaker producing sound wave, a loudspeaker producing sound wave, and the frequency of the sound is constant. The question is, what is meant by frequency? What is meant by frequency? You know, frequency is number of vibration per unit time, or number of sound waves in per unit time. If you write number of vibration per unit time, ये भी काफी है, is called frequency. So frequency is number of vibration in per unit time. And now um we have a question about diffraction of sound wave. The next question is about diffraction, which we have done in the last week. But now the question is, what is meant by compression? We have discussed that compression is a high pressure region. Compression is a high pressure region. Rarefaction में low pressure, Compression is a high pressure region and particles are very close to each other. Particles of medium very close to each other. Particles of medium very close to each other. So when particles very close to each other, then it is compression. Then it is compression. And now the next part is about diffraction, which we are not interested to discuss because last week we have completed diffraction. We have completed diffraction. This question is very simple, which we should not solve. We should not solve. These questions are very, very simple. So we are not solving. But I think this question we should solve. This question. The question is the sound is produced by loudspeaker and consider the sound is produced in air and then this sound enter into water. And now we have to discuss, we have to compare their wavelength. बेटा राफे बेटा आपके माइक्रोफोन से शोर आ रहा है यार माइक्रोफोन बंद कर लीजिए अच्छा बेटा हम यूं बात कर रहे थे कि कंपेयर द वेवलेंथ ऑफ साउंड in air and in water. In air, the speed of sound is slow. The speed of sound in water is fast. Okay. And wavelength and speed are directly proportional. If the speed is slow in air, so wavelength in air will be shorter. Wavelength of sound in air is shorter. And this sentence is enough. Do not write about in water because I have explained in air speed is slow, so wavelength is shorter. In water speed is faster, so wavelength will be longer. Actually, again, there is a diffraction question. There is a diffraction question. And remember, the wavelength of sound is very, very longer than wavelength of light. So sound easily diffract. Remember, the diffraction of sound is very easy, and the wavelength of light is very small. So, diffraction of light is very difficult. It is just a comparison. And now, the question which we have discussed in the beginning of the class, if the pitch of the sound is increased, if the pitch of the sound is increased, then obviously frequency increases. Pitch depends upon frequency, and just after my class, I will share you a video of just 2 minutes, but must watch that video and it will clear you the pitch of the sound. It will clear you the pitch of the sound, the concept. And now the loudness of the sound. So the loudness of sound depends upon amplitude. If the loudness increased, then the amplitude of the sound will increase. And now a person is walking on the moon. And the question is, there is no sound on the moon. What is the reason there is no sound on the moon? So the answer is, sir, sound cannot travel through vacuum. Sound cannot travel through vacuum. There is no atmosphere around the moon. There is no atmosphere around the moon. So sound cannot travel through vacuum. Very simple question. This question is very simple. We are not solving. This is diffraction. We are not solving. I am searching a question on echo. I am searching question on echo and speed of sound. Yes. This is another question which you must memorize. This question is known as speed of sound. This question is known as speed of sound. So in this question, there are two students. There are two students. Student number one, and consider he is another student, student number two. These two students are in an open field and consider the distance between them is 1000 meter. And you know this distance can be measured by measuring tape. So the two students are standing at a distance of 1000 meter. And now the one student have a pistol and the other one has a stopwatch. Okay, but the first student has a pistol. Consider this is a pistol. Consider this is a pistol in his hand, and the other student having a stopwatch in his hand. Okay, and the question is they are standing at a distance of 1000 meter. The first student fires, and obviously when he fires, a loud sound is produced as well as a spark is produced or a puff of smoke is produced at the same instant. Obviously, when the bullet is fired, loud sound is produced as well as a spark or a puff of smoke are produced. You know, sound takes time because it sound travel slower. Whereas if there is a spark, then spark means light, and the speed of light is so fast it does not take time to travel 1000-meter distance. So as the student number one fires the bullet, then he starts stopwatch, and when he detected loud sound, then he stops the stopwatch. And in this way, this student is measuring time of traveling of sound. The sound is coming from student number one, and the sound is taking time, and this sound is measured by stopwatch. So the time is measured. And you know, these two students are human, so they can make mistake. So if their positions are interchanged or pistol and stopwatch are interchanged and the same method is repeated again by changing their position and their devices, then the same reading you can take again, and obviously the reading will be different. So you will take their average, and when you noted the average, then speed is equal to distance upon time. So distance is already measured, and time is measured by stopwatch. Consider the time is 3 seconds. Then the speed of sound will be 330 meter per second. So you can calculate, you can measure the speed of sound by this experiment. And I have written its proper answer in my notes. And just after my class, I will share you my notes in which I have written the proper answer of this question. So I have explained the question, but not writing because this is a crash course in which I have to teach you very fast. So you will write the answer here. The next question is very simple. I am searching question on, yes, this question I was searching. This question I was searching. The question is, sir, this is ultrasound probe, and obviously it will send ultrasound waves, and the speed of ultrasound wave is given. The speed of ultrasound wave is given. Okay. This ultrasound travel from X to Y and then returns. And then returns. And from X to Y and back to X, you are given time. You are given time. Okay. And you have to calculate the thickness of the bone. This is thickness of the bone. And you can see the ultrasound covering thickness T in going and thickness T in returning. thickness T in outgoing, and thickness T in returning. These are thickness. This is not time. Actually, this is just like distance. So I should say distance is equal to thickness. In this question, distance is the thickness. So I should write, sir, distance is equal to speed into time. Sir, we are given speed. Speed of ultrasound is 4100. Speed of ultrasound is 4100. Yeah, yeah. We will use 2D. And the times, our time is 9 exponent minus 6. Time is 9 exponent minus 6. So if you calculate distance covered by ultrasound, then this distance will be the thickness. And I think by using calculator, you can calculate distance. So in this 1 hour class, I have completed sound wave at a very fast pace. Or